Hello and welcome to lesson number 3 in Unit 1, Functions, in our grade 11 University College math class. This is domain and range. So this last lesson is a bit of a beast. It's big and there's a new concept we're going to introduce to you today. So it's going to be a long series of videos, so just buckle in, listen up, follow along in the notes and you'll be just fine. So before we talk about domain and range, I'd like to talk about number sets first. Normally in class we do a nice long discussion about this. I'm just going to move through it fairly quickly today, just in the spirit of getting things moving along. So what we have here are variables or letters that stand in for certain sets of numbers. And the first set of numbers we're going to look at is characterized by the letter capital N. And this set of numbers is called natural numbers, and it includes 1, 2, 3, 4, etc. They're whole numbers. Doesn't include 0 or any negative numbers. They're just natural, basically like counting numbers, I guess you would say. The second type of number we're going to look at is characterized or represented by the capital letter W, and it denotes all whole numbers. So this is exactly like natural numbers, except it includes 0. Again, all just integers, there's no decimals, no negative numbers, just whole numbers, including 0, 1, 2, 3, etc., all the way up. Now, we don't spend a lot of time working with natural or whole numbers in math. Those are more practical when you're dealing with everyday situations. These last two number sets we're going to look at, those are the ones we're going to be spending some quality time with over the course of this course. The next one is a set of integers. Integers we represent with the letter capital I, and this includes all whole numbers, which of course includes natural numbers, but it also includes all the positive and negative numbers, including 0. Again, no decimals, no fractions, nothing like that, only whole integers, positive and negative. And the last number set that we're going to look at is represented by the letter capital R, and this is real numbers. This is basically any number that you can imagine. Let's just read the definition actually. So a capital R, which stands for real numbers, includes all integers, so it includes the 3 number sets we've already discussed, including integers, also fractions and rational numbers, so terminating decimals and repeating decimals. So a terminating decimal is like 1 over 4, so 0.25, it ends, it terminates. And we talk about repeating decimals, that might be like 1/3, where it's, if you were to write it as a decimal, it would be 0.3 repeating. So that is also a real number. It also includes irrational numbers, so that's non-terminating, non-repeating decimals. That's something like pi. Pi, of course, is a number 3.1415, etc. It goes on forever, as far as we know, and doesn't have a discernible pattern to it, and it doesn't end. It just kind of keeps going. So real numbers includes irrational numbers, rational numbers or fractions, integers, and all that other stuff that we talked about in the other number sets. So it's the broadest category. It's the catch-all, if you will. Now that we've discussed number sets, let's get down to talking about domain and range. Now there's a definition of domain right here, and the definition says the domain of a relation is the set of all horizontal or x elements of a relation. The domain describes the values that are acceptable for the independent variable. And that's important too, I think, to note that when we're talking about the domain, we're talking about the independent variable, the one represented on our horizontal or x-axis. So we're going to start by talking about domain. Let's leave range out for now. As I said, when we're talking about domain, we're talking about all of the x values, the ones that come from the independent variable or the horizontal axis, that are a part of a given relation. Now, domain can be communicated in words, using a number line, or as a set, and we're going to spend a lot of time talking. If this were a regular class, if we were talking about it in the classroom, we wouldn't do a lot of writing down of the words, we would do a lot of saying of the words. We're going to use number lines as a way of sort of getting into what domains are all about, and we're not going to spend a lot of time on number lines after we sort of grasp the concept. We will be spending a lot of time doing set notation, and I will be doing a lot of saying the proper set notation in words. So with that set up, let's get a look at this horizontal axis. This would be just sort of a model, a number line of our horizontal or x-axis. And we can see here, this was obviously pencil drawn and scanned in, but we have it right here. So let's get a look at this. I like to call this as like an actionable point right here. We can see that the dark line, which would represent the x values that are applicable for this particular relation, it starts here at 1, and then it continues up in this direction with the inclusion of this arrow forever. So how do we go about saying that if we're talking about describing the domain? Now I'm going to get you to pause here. There's a really long set of words right here in the middle of the page. You don't have to write this down over and over, but it really is important that you understand that each word corresponds to a particular symbol. Set notation we're going to be using a lot more often. So take a moment now, hit pause, and write these words down, and then we'll talk a little bit about just what it means. So hit pause, write this sentence down. Again, we're not going to be doing this often, so write it down, come on back, and we'll talk through it. Okay, you're back. It reads, the set of all x such that x is an element of real numbers where x is greater than or equal to 1. So let's unpack some of this stuff. And we're going to unpack it as we look at the set notation, which is written down here. So when it says the set of all x, so I'm going to just try to do this with some color coding here if I can. So when it says the set of all x, the set of all x is like an introduction. And this is the introduction piece here, the little curly Q bracket. So it says the set of all x, that corresponds to the little curly Q bracket, and the x, we're basically saying what variable are we talking about. So that we've started this with the set of all x, we know that we're talking about the domain. That's our independent variable on the horizontal axis. And then it says such that, set of all x, such that, that's this little vertical kind of slash here. And that is a way of setting up what's about to follow in terms of qualifying what our variable is going to all be about. So we have the set of all x such that, and then we have here a declaration of what set of numbers we're dealing with. And the set of numbers is the stuff we talked about up above. We have natural numbers, whole numbers, integers, and real numbers. So this, x is an element of real numbers, is depicted right here. X is an element, that's a Greek symbol of inclusion. So x is an element of real numbers. Again, we're using the variable set up above. That's our capital R. Actually, let me just scooch that over a little bit. That's our capital R. So again, let's have a look at our number line, and why are we talking about real numbers here? The reason that we're talking about real numbers is because the line that we're given not only starts on 1, and there's 2, and there's 3, etc. It's not just 1, which we might represent with a dot, just 2, and just 3. It also includes all these little values here in between that fill up the numerical space, if you will, between 1 and 2. So that would be like 1.1, 1.1 repeating, 1.0001, like any sort of little, and again, this is why we're talking about real numbers as opposed to integers. Integers would just be 1, 2, 3, etc., 4, 5, going on. This one includes all the little pieces in between. So how do we go about saying, okay, so we know we're talking about real numbers for the x's, but we have a limit here, clearly. Nothing less than 1 is going to be included on this. So we want to set up here what in words I would call like a qualifier. I'm going to change up my colors again. So we have the set of all x such that x is an element of real numbers. Now this right here, where, that's this little comma here that's just sort of setting up whatever set of conditions we have to put on this, a set of limits. Basically we're saying it's not all the real numbers, there's limits on which real numbers we're talking about. And then it follows to say where x is greater than or equal to 1. And that obviously is depicted right here. Let me change up my colors again. What do I still have left? Let's do red, I guess. So x greater than or equal to 1. Where x is greater than or equal to 1. And as I said, that's the very last part. It's sort of fully articulating the limits on our domain. So I'm going to read this one more time. And it says, and as I'm reading it, maybe have a look at the symbols in our set notation, which is that part kind of just down here. And it says, the set of all x such that x is an element of real numbers where x is greater than or equal to 1. So this is a very formal mathematical system of articulating which portions of the independent variable are accessible to us and what the number set is that they include. It's giving us information. So let's move along to a second example. We have another number line here. So again, we've sort of got our horizontal axis so we can see that. We're going to write out, now I'm not going to bother writing out all the words again. It's just too much. It's too much for sure. But what I would like to do is spend some time looking at the number line. So what do we know by looking at the number line? Well, we have another actionable point here, and the actionable point is going to be -1. That's kind of where our domain starts, and it goes through 0 and 1, and it ends up here at 2. So we not only have a lower limit, but we also have an upper limit. It's kind of all the values that are in between that. So what we want to do is first determine what kind of number set are we talking about here. Well, I can see that this is a continuous line. Starts here at -1, kind of, and then it includes all the little tiny little fractions and rational numbers in between 0 and 1, in between -1 and 0, in between 0 and 1, and in between 1 and stopping at 2. So this is going to be, if you haven't already guessed it, this is going to be a set of real numbers. And the mathies, at least my kind of mathy, I guess, we don't just write a capital letter R, we kind of put like a little double left-hand side on that thing. And so we have real numbers. Now I want to just talk a little bit about the way that this is, depicted. And the way it's depicted is, you'll see here that we have a closed circle. Let me get some highlighters going here. We have a closed circle here, and a closed circle includes the point. So I'm going to make a note of that. Closed circle includes the point, meaning that circle includes the point. So what I mean by that is this domain goes up to 2 and includes the numerical value 2. So includes the value. And that stands in contrast over here to this open circle. And an open circle excludes the value. Open circle excludes the value. And let me finish writing this, because apparently I can't do two things at once. And then we'll talk about what that means. So an open circle excludes the value. What that means is that this domain goes up to, approaches, and gets as close as you could possibly imagine to -1, but doesn't actually include the value -1. Now -1's a good marker for us. We know that that's the lowest point before you start into your domain. But there's a distinction between closed circles and open circles, and that's the distinction that I want you to just understand from this. Okay, so this video is getting a little bit long. Let's get a set notation for this domain on here, and I'll talk through it. So we would say the set of all x such that x is an element, as we've decided, of real numbers, where, oops, that should be a comma, where, and now we're going to set up some limits. Now the way to set up the limits on our domain is to write it down very much like I've written it here. I know that my lowest point is going to be involved in some way -1. We're dealing with x's, and my highest point is going to be 2. Now I want to put some inequality signs in here. Now I know that x is going to be less than, and because it's a closed circle, it's going to be equal to 2 as well. It's going to be less than and equal to 2. And this is sort of a little fancy way of writing it. Technically what we're writing here is x is going to be greater than, but not include -1. But if you can imagine sort of literally flipping this whole presentation around where you've got -1 and x, so -1 being less than x, these are equivalent. These two things are exactly the same. We're going to be writing it the bottom way, so this way down here, because we need to articulate our limits in one fell swoop. We can't just set up multiple conditions, we have to set up one sort of larger condition. So what we want to write down here is that -1 will be less than x, which, as I said, is sort of a fancy way of saying x is going to be greater than but not equal to 1. Sort of an inverse way of writing it, I guess. So there you have an introduction to domain and a little look at number sets and set notation. When we come back, we're going to do some more work with domain, and we're going to jump right into range. So buckle up, the good times are coming at you.